This is section 5.2. We're looking at the area of parallelograms and triangles. So our learning goal for this is that students will be able to calculate the areas of parallelograms and triangles. So we have three different success criteria. The first thing that we want to be able to do is find the area or perimeter of a parallelogram or a triangle given the base and the height. So if you know the base and the height, basically just calculate the area and the perimeter of that parallelogram. The second one is I can find the base or height of a parallelogram or a triangle if I've been given its area. So here we're going to be using the formulas to work backwards to find pieces of parallelograms and triangles. And then of course the last one is I can explain how the formulas for the area of a parallelogram and triangle are developed. So where did these formulas come from? We want to be able to explain that clearly to each other. Okay, so let's get started. First of all, when we're looking at a parallelogram, there are two parts that we're interested in, the base and the height. And like we talked about in class the other day, a lot of times we think about the base as being the side that's on the bottom of the parallelogram, right? So like this is the base. And that's fine, it might be true. The base might be on the bottom. If that was the base, then the height would be perpendicular to it. We know it's perpendicular. We see the right angle here. And so the base and the height are always perpendicular to each other. But when we're looking at a parallelogram, any side of the parallelogram can be the base. So I wanted to show you a couple of examples here. First of all, if this is the base here, there's two different places where we could draw the height, or two different places where we usually draw the height. And those two places extend from either vertex of the side opposite. So we could draw the height perpendicular to the base here. Or if we were looking at the other vertex, sometimes the height might extend outside of the parallelogram. But you can see how both of those segments are the same. Okay, so looking at that same parallelogram, if we chose this side here to be the base, then we could draw the height from this vertex over here, again drawing it so that it's perpendicular or makes a 90-degree angle with the base. Here's another example of how we could draw that height. We might have to extend the base a little bit and then draw in the segment that's perpendicular from the opposite vertex. Okay, so now we know how to define the base and the height of a parallelogram. Now let's talk about how to calculate the area. And I wanted to show you a little animation here because I think it's a really good one that really shows how the area of a parallelogram is developed. So here you guys can see we have this parallelogram. In this particular case, the height is 5 and the base is, let's see, 1, 2, 3, 4, 5, 6, 7, 8 units long. The base is 8 units long. Oh, it says that right here. The height is 5 and the base is 8. Well, to calculate the area, or how many squares this parallelogram covers, what we're really going to do is calculate the area of, watch this. Oops, just kidding, don't watch that. Watch this, we're going to move this. We're going to cut that little triangle out where that height is, and we're going to move it to the other side of the parallelogram. Now you can see that the shape that we really have is a rectangle. Like we talked about in class, the area of a rectangle is its base times its height, or in this case 8 times 5 is 40 square units. And if you were to count all these little squares in here, there's 5 times 8 squares, there's 40 squares inside that figure. So it makes sense that if all I'm doing is moving this triangle to the other side, there's 40 square units in this figure as well. Okay, so let's go back to our notes and let's write that down. The area of a parallelogram is the product of its base and its height. Or in other words, the area is equal to the base times the height. A equals BH. It's the same formula as that for a rectangle. That's awesome. Less things that we have to memorize. But one of the things that I want you to be able to do is explain how the formula for a parallelogram is related to the formula of a rectangle. Oops, that should say rectangle right here. Make that change, that question. How is that related to the area of a rectangle? All right, let's do a little bit of practice. Let's find the area of a parallelogram with vertices at 1, 2, 6, 2, 8, 5, and 3, 5. So I've already plotted those points here and connected them. So you can see I have a parallelogram. The base is 1, 2, 3, 4, 5 units, and the height is 1, 2, 3 units. So if my area is equal to the base times the height, that's 5 times 3, that's 15 square units. If no unit is given, like inches or centimeter, we say that the area is in just square units. All right, let's do another example. Given the parallelogram that we see below, let's find the length of CF. Okay, so here we know that the height extending from D to the base is 12 inches. And we also see that this base is 10 inches. So if I'm looking at this base AB, segment DE is the height that corresponds with it. So the first thing we're going to do is calculate the area using a base and a height that we already know. So we can say that the area is equal to base times height. In this case, that would be 12 times 10, or 120 square inches. Okay, so now we know that area. We're going to use that known area to find this other height. Shouldn't this height here times this base here give us the same area? So start with our formula, area equals base times height, and plug in the values that we know. We know the area is 120, we know the base is 13, and we're trying to find that other height, CF. So to undo multiplication, we divide by 13. We divide both sides by 13. And doing a little computation here. I don't know that one off the top of my head. Let's see. 120 divided by 13 is going to be, let's see here, get out my calculator. About 9.2 inches. And this is a height, so this isn't going to be square inches, it's just 9.2 inches. All right, good. So now let's talk about the area of a triangle. The area of a triangle is a lot like finding the area of a parallelogram, but it's only half as big. The area of a triangle is 1/2 the product of its base and its height. So here's the formula for the area of a triangle. We'll explore that a little bit more in class. Okay, again, just like a parallelogram, the base and the height must be perpendicular to each other. So the height's going to extend from the opposite vertex perpendicular to the base. All right, so let's do an example working with the area of a triangle. Let's say we know that the area of a triangle is 20 square centimeters. Let's say we also know its height is 5 centimeters. Let's find the length of the base of the triangle. So we start with our area formula. Area equals 1/2 base times height. Just like with the parallelogram problem, plug in the information we know. We know the area is 20. We know the height is 5. So 20 is equal to 1/2 times the base times 5. Another way of writing that is 20 is equal to 5b over 2. Now I don't really like that fraction, so I'm going to get rid of it by multiplying both sides by 2 to undo the division. Okay, so 20 times 2 is 40. So we have 40 is equal to 5 times the base. If we want to isolate b, we'll undo that multiplication by dividing both sides by 5. Scroll down here, and 40 divided by 5 is 8. But wait a minute, let's go back and think about what units we were working with. Centimeters. So we know that the base is 8 centimeters. Okay, let's do one more. Let's say we want to find the area of a triangle that's enclosed by these lines. Y equals 0, x equals 0, and y equals negative 2x plus 4. Of course, we've got to graph those lines first. So remember y and equals 0 and x equals 0 are really like horizontal and vertical lines. So y equals 0 is here along the x-axis. Whoopsies. Let me fix that. Right here along the x-axis. X equals 0 is actually along the y-axis because the x-coordinate is 0 everywhere. And y equals negative 2x plus 4 has a y-intercept of 4 and a slope of negative 2. So down 2 over 1, down 2 over 1. It's going to make that line look like this. Okay, so now we can see that triangle. We can find its area. Fortunately, two sides of the triangle are perpendicular to each other, so I can see that the base is going to be 2, and the height is going to be 4. So plug into my formula. Oops. Area is equal to 1/2 base times height. So that's going to be 1/2 times 2 times 4. Half of 2 is 1. 1 times 4 is 4. So my area is 4 square units. Okay? So we'll do some practice finding area with graphing as well in class. So I want you to go ahead and write your summary, get your area formulas in there and a couple other important points, and we'll do some practice on this in class.